Okay, so let's look at those were exponential. Now we're going to look at steps for solving logarithmic equations. So one of the first things you want to do is is to check the one-to-one property. If log bm is equal to log bn, then m is equal to n, so we can solve for the variable. If you cannot use the one-to-one property, then we want to express the equation in the form as follows. If you have this log bm equals c, we want to make sure it looks like this. Once you have it like this, then we can write it as an exponential equation. And so this, if we rewrite as exponential, will become b raised to the power of c equals m. Once we have it that way, then we can solve for the variable. And then you want to check your solution. The expression for m in here must be greater than 0 because of the domain. So let's look at example 4. We have log 3, 5x minus 1, log 3x plus 7. Notice here that the base is the same. So I can use the one-to-one property, which tells me that I can set f 5x minus 1 equal to x plus 7. I'm going to subtract x. So I get 4x, and I'm going to add 1. So we get that x is equal to 2. We need to check our work, or check our answer. Okay, so if I check my answer, I'm going to have log 3 of 5 times 2 minus 1 is equal to log 3 of 2 plus 7. 5 times 2 is 10 minus 1 is 9. Notice that the 9 is positive, so we're good there. And 2 plus 7 is 9. So here again, we get it to be positive. So that means that x equals 2 is the solution. Okay, let's look at the next example. So here it's not set up as one log. In fact, it has 3 logs. So, however, they all have the same base. So if we can somehow have one on this side and one on this side, then we can use the one-to-one property again. And so let's try to combine these with our properties from 3.2. Since I'm subtracting here, I can put these together as division using the quotient rule. And so now I'm left with just 2 logs with the same base. So I can set x minus 3 is equal to 7x minus 23 divided by x plus 1. Multiply x plus 1 on both sides. So x times x is x squared. 1 times x is x. Negative 3 times x is negative 3x, and minus 3. Gather like terms. This is quadratic, so all the terms should be on one side. And so now we can try to factor, or we can use a quadratic formula. So here I'm going to have minus 4 and minus 5 are my factors. And I can set each factor equal to 0. So x is 4 and x is equal to 5. We need to check our solution. Okay, so we have natural log of, let's check 4 first. 4 minus 3 is equal to natural log of 7 times 4 minus 23 minus natural log of 4 plus 1. 4 minus 3 is 1. 7 times 4 is 28 minus 23 is 5. Natural log of 4 plus 1, that's natural log of 5. So they're all positive. Okay, so that's okay. And then for 5, if we plug in 5 in here, 5 minus 3 is 2. That makes it positive. 7 times 5 is 35 minus 23. That's going to be positive. And 5 plus 1 is 6, which will make it positive. So both of these are going to be our solutions. Okay, let's try letter D. Notice here I don't have two logs, so I cannot use the one-to-one property. However, this looks exactly like this form. So I'm going to go ahead and change it to exponential. So my base here is 2. The log is always equal to the exponent. So this log is equal to 3. So that makes 3 the exponent of x minus 4. 2 cubed is 2 times 2 times 2, which is 8. Add the 4 on both sides. So we get 12. Don't forget, we need to check your answer. So 12 minus 4 is going to be positive, so that's okay. Let's go ahead and try the next one, letter D. So here we also need to isolate the log here before we can change it to exponential. So I'm going to divide by 4. Remember that the natural log is the same as log e. So my base here is e. The log is equal to my exponent, in this case 2, of 3 to the x. Divide by 3. So e squared is equal to 3. Divided by 3 is my solution. The approximation, if you enter it in the calculator, is 2.463. So if I enter it on the calculator, I get second e raised to the power of 2. And I'm going to divide that by 3. And so we get 2.463. Letter E. So we have log x. So here we can combine these two logs. Since they're being added, I'm going to multiply them. And I'm going to change this to exponential. So my base here is 10. The log is equal to my exponent. So x times x is x squared minus 3x. Bring the 10 over. You can try to factor or use the quadratic formula. Set your factors equal to 0 and solve for x. Check your solutions. If you plug in 5, that's positive. 5 minus 3 is still positive, so that is a solution. If I plug in negative 2, I get log of a negative number, so that's not a solution. And then the last problem here, subtract by 7 on both sides. Divide by 3. So here the base is e, and it's raised to the negative 2/3, since that's what the log is equal to. So if we plot that in the calculator, we get second e raised to the negative 2 divided by 3.5134.